Okay. Hey everyone. Super glad to see that you've all made it to the final chapter. We have done a lot of hard work and learned a lot to get to this point. In chapter 4, we've ended off with this cube, which we have troubleshooted any problems related to UVs to ultimately set us up for applying materials in this lesson. So, what are materials in Blender and why do they matter? Materials define how your model looks when it's rendered or placed into a scene or video game. They control aspects such as color, glossiness, metalness, roughness, transparency, but generally how light interacts with the surface of our object. Without materials, we just have geometry, but with it, we actually get something that feels real. So in chapter 4, we've actually gotten a little bit of a sneak peek on how we created materials in the shader editor, because that was how we set up this UV grid, which is this material that we're seeing in front of us with this checkered image with plus signs on the model. Again, what we're currently looking at. But we've run through that process a little bit too fast, so I'm going to backtrack and refresh our memories about how to do it properly from the start. So, when we're working with materials in Blender, we complete this process in the shading workspace. In the shading workspace, we have some familiar areas here. We have the 3D viewport on the top. We got the outliner on the top right, properties editor on the bottom right, and we also have a few additional areas. We have the shader editor on the bottom, which is a node-based editor where we are connecting nodes containing material information to each other. We also have a file browser on the top left, which accesses the files on your computer in case we want to save or import images. And then lastly, we have the image editor on the bottom left, which we can view any images that we create basically using this browse image dropdown functionality, or creating a new or opening an image as well. Now in the shading workspace, we are going to do a lot of our work in the shader editor right here. Okay, and this is because that the shader editor holds the logic of creating these materials. And through creating the logic and connecting the nodes up, we're essentially using our 3D viewport to view what we're doing in real time. And we're also going to be using the materials tab in the properties editor, in which we can access quickly any materials that are currently assigned to our object. So right now, we could see that in the properties editor, materials tab, which is this tab right here, that whenever we select a mesh, you might notice that the name right here updates to whatever mesh that we are currently looking at. And this box right here tells us how many materials this selected mesh currently has. If we click to any of our meshes in the scene, as I ran through a little bit just now, we would see that all of them only have the one material, which is the UV grid material that we created for this checkered image texture. Now, to be quite frank with you, materials is sort of its own art form, and you could theoretically or technically make an entire course dedicated to all the different aspects of the shader editor and showcase a bunch of interesting and cool designs that you can make. However, as we are newcoming Blender users, I think it's best for us, or me, to start by explaining the principles of how all of this works, and we're going to cover the basics. And of course, when we get the hang of it, your imagination is your own limitation. So with that said, I'm going to hide this crate and talk about materials using a cube. And once we've run through the logic about materials onto this cube, we can then apply that logic onto the crate itself. So, when an object has no materials, which we can confirm because this box right here in the materials tab is empty, we want to create a new material. And to do that, in the shader editor, we're going to click this new button right here on the top. Now, clicking this new button is going to do the exact same thing as clicking this new button in the materials tab, but For consistency reasons, let's just stick with only the shader editor. So, when I click this, a couple of things happen. 2 nodes get automatically added into my shader editor, and the Materials tab updates to reflect that our cube now has a material applied to it. When we're creating a new material, we should always start by naming it appropriately. Now, since I'm running through an example here, I'm just going to call this example material. And by renaming it here, it also gets updated into the Materials tab as well. Now, to move around into the shader editor, we can scroll on our mouse or move our fingers closer or further away from each other on the touchpad to zoom in and out. And to move around, we can hold the middle mouse button and drag, which does the same thing as 2-finger scrolling on a touchpad, depending on whatever setup you have. So, what are these 2 nodes that we just created? The large green node over here is entitled Principled BSDF. And this is going to be your most important node, at least in my opinion. This node combines multiple layers into a single easy-to-use node that will reflect the attributes of your material. You could see just from the layer names listed that these are the settings of this material right now. We have a almost white-ish base color, no metallic value, about half the roughness value, and so on. This node, just like any other node, has input and output values. All of these circles on the left of the node are input values, meaning that the principled BSDF can take input from values of other nodes, but otherwise, when there's nothing being inputted, like we have right now, it's going to reference these default values that we set. On the right of this node, we have only one output, which is called BSDF. If you're curious, BSDF stands for Bidirectional Scattering Distribution Function, which is just a fancy mathematical concept that describes how light reflects, transmits, or is scattered around a material, ultimately giving us this appearance. So, once we've set up all the desired values for each layer in the principled BSDF, we then output that BSDF value, which is our entire material's appearance, onto the surface of our object. So you can see that if I disconnect this surface value, which I could do just by dragging off the wire from it, I just get a complete black void. This is because our material is currently not referencing any light behavior. So this is the absence of light that's happening right now. Now, because we want our material to show up on the outside or surface of an object, so we can actually have a material to look at, this is the reasoning behind why we connect this BSDF value into the surface input of our material output, basically telling Blender, use this value. As for the other options of this material output, it's not something that we're going to be worrying about. And frankly, it's not something I rarely worry about either. Okay, and an additional thing that I'd like to mention is that we also see that these nodes have different colors. And the color coordination that Blender is using them for is different types of values, which we're going to see a little bit. So, for instance, the gray icons usually are just a nice singular scalar value. Yellow typically means color. The purple one usually relates to vectors a little bit, and so on. There's a ton of different colors that we could look from. Okay, now that we can preview work that we've done on the principled BSDF, let's take a closer look at each of the layers that we have here. So the first layer in the principled BSDF is base color, and this layer sets our diffuse color, which in general is the default color when the light shines on our object. I can click this color bar over here to open up a more detailed color interface, where I can then set the color using this color wheel. I have a brightness slider over here. I could also input RGB values, HSV values. If you have a hex code, you could put that in here, or you could use an eyedropper to choose a color as well. The metallic layer controls how metallic an object is on a scale from 0 to 1. So 0 represents a non-metallic surface, and 1 is a completely or full metal surface. The roughness layer controls how rough or shiny an object is from a scale of 0 to 1. So 0 is a completely shiny object, like a mirror, and 1 is not shiny at all, and hence very rough or dull. Now if you noticed that when I set this roughness value to 0, and hence we have a very mirrored-like object, you could see that there's something happening in the background. Our cube is reflecting something. And if I zoom in a little bit, I could see that it looks like a little bit of trees. I see a little bit of fences going around here. I think I could view this better if we decrease the brightness. And yeah. So we got some rocks, some fences, some trees. That's going on here. Now the reasoning why this is happening is since the BSDF reflects light behavior, Blender has actually given us a default background scene to look at, which is actually a forest area, which is also this little sphere that we see here, if you can make that out. Okay, if I also find a complete view of the model, I'll put it on the screen as well. That's only if I find it. And again, the purpose of putting this setting is that Blender is allowing us to model light and sunlight in a realistic setting. So if you could just imagine that you are standing in the middle of a forest. You know, you're looking everywhere, you see rocks, you see trees, maybe a river, doesn't matter. And then in the sky you have this cube floating. With these BSDF or light settings, this is what your cube is probably going to look like. Moving on, the IOR layer, which stands for Index of Refraction, controls how strong the reflections are. And it's using a real number that's greater than or equal to 1. Okay, now we're not going to be messing around with IOR too much, so I'm going to set it back to the default value of 1.5. The alpha layer controls the transparency of the surface of an object from 0 to 1. Let's put back some default settings here. Let's get back our greenish color that we kind of had around there. So 0 is a completely transparent and 1 is completely opaque. Now to us, both of these look like it's opaque, and the reasoning behind this is that the alpha slider usually goes hand in hand with the image texture, which is another specific node here that we're not going to be looking at. So controlling this alpha slider at this stage really does nothing, except when it's at 0, it's black, and any other value, it's something else. So it's not too important for us. And then finally, the normal layer here, it controls the normals of the base layer, which is pretty much that the direction of all the pixels on the face of the surface of the object, you know, where is it pointing? And if we can tweak the directions of each of the faces and the strength of each of them, we can create very, very fine details. Now, normals go hand in hand with something called normal maps, which is another type of image texture. But again, that's its own little battle and out of the scope right now. So it's not something that we're going to be looking at. So I know what you're thinking right now. You know, Dylan, we can't even use half of these. What's the point? And honestly, I get it. But let's remember here, this is a beginner's Blender lesson focused around modeling. And we are primarily giving you the tools to create your own unique geometry. And I also did say in the beginning that materials is essentially its own battle. Now, although we need to start somewhere, which is what we're looking at, base color metallic roughness, that doesn't mean we can't have some fun and still create millions of different designs. Now, because I know that just having a plain color like this is super boring to look at, I'm going to show you some additional pretty cool and fun nodes that will help you make designing a little bit more interesting. So, to access nodes in the shader editor, we can click this Add button, Then you can go down in the drop menu, choose a desired node. Let's just choose one at random. I'm going to select it, and you can click it somewhere on the black background to confirm it. Deleting the node, you could just press delete on your keyboard. And another handy tip is that Shift A is also the shortcut for that menu, but this also gives you the option to search for a node if you already know the name of it, and it also gives you access to some of the more recent ones that you've played with as well. So let's take a look at a few of them that are probably super common that you're going to find yourself using. So the first one is under converter. We're going to select the color ramp node. The color ramp node allows you to set your own color scale. The default values that we have here is we have the color black on the very left and the color white on the right side. And you could change this color by selecting these color stops, then selecting the color bar and using the color wheel or any of the other menus to just choose a color that you like. The colors in between these two are a gradual scale that are transitioning between these two colors. And we can move around these color stops based on this positional scale from 0, which is all the way on the left, to right, at a value of 1. And I could do this just by dragging them. To create a new color stop, you can click this plus button. Over here, it's going to add one. You can move it around the same way and select the new color, whatever you desire. And you could delete color stops similarly by selecting an active color stop, which you can see is selected with the dotted line above it, and it will remove it completely. Now, the number on the left of this color stop is the index. And the index is a positional scale, or an index scale, based on its position from left to right. So my leftmost color stop, which is this green one, has an index of 0. And you can see that if I drag this, it stays 0 until it passes my red color stop, in which the index jumps up to 1, and now my red color stop has the index of 0. So I'll move it back. Now, in terms of outputs, we're going to focus a lot on the color output. And the color output holds the color information from your color ramp node. And because we already have a color set or a gradiency scale set, let's see what happens if I drag out of this color output to get this wire and input into the base color of our principled BSDF. Now you might be thinking and looking at this, well, how did I get this color? Given our current setup, the color that is being shown up here is determined by the factor of the color ramp, which maps its value to a position on your color scale, and whatever color that it sees there is going to use it. So if you can sort of follow where this blue bar matches. This blue bar is that 0.5, so we're looking at what color is in the 0.5 position. So I could just move my mouse up to get a rough estimate, and I could see that I get this sort of pinkish color. And this pinkish color comes from the fact that, well, I have my green to red area here, but the 0.5 really lands between this red to white area, mostly towards the red side, so I get a slightly lighter red color, or pink or salmon, whatever you'd like. Now, I know what you're thinking. This is really just no different than if I didn't connect this at all and just manually selected that color using this color wheel. I thought it would give me a little bit more of a gradient look. Kind of disappointed. Now, I get that, but I would say hold on just there, because we can actually do what you want. Remember to ourselves that our 3D model here has UVs, and UVs are a coordinate system. So we can use that coordinate system to tell Blender that, hey, depending on the coordinates that you have, map it to a factor in the color ramp. And hopefully with all these different factors that we have, it will help us create a more gradient look. Now, how do we do that? So the way that we're going to do that in Blender is we are going to add a texture coordinate node, which could be found under input texture coordinate. And we're also going to add a mapping node, which could be found under vector mapping. Now with this setup, to achieve the result that we want, we are going to connect the UV output of the texture coordinate into the vector input of our mapping. Now because our UVs use a 2D space to reflect faces on a 3D object, by connecting this UV to vector over here, we're essentially taking our UV's 2D coordinates and getting the corresponding vector in 3D space in our scene. And setting our type as point allows us to do this straightforward transformation. This is very, very similar to back in the UV editor, how this 2D image over here, or island, gives us the corresponding 3D object over here. So it's a similar transformation that's happening. Now that we have our UVs in 3D coordinates for our model over here, we could then take that vector and connect it to the factor of the color ramp. So yes, a vector is a 3D value, and a factor is a scalar or a one-dimensional value. So some formula will be needed to translate between these two types of values, similar to how the 2D coordinates translated to the 3D vector. Now, I believe the default process that Blender is using is just averaging the components of that vector. So that would be taking your x, y, and z coordinates, adding them all up together, dividing by 3, so the average of it, and the result that you get from that is a scalar value. I could be wrong on that, but I think that's the default value. Anyways, we've converted our UV coordinates to a scalar value through a function that's being represented by these nodes. And now, if I connect the color output down to base color, I should expect something a little bit more gradient. So let's do that. And take a look at what we have. We have some gradient action going on over here, but again, this result ultimately comes from the UVs. So if I take a peep at the UV position over here, this is the default position. Now, if I select all of it and I move it around, you could see that on the right side of my screen that the gradient is going to change. So this proves to us that the UV's coordinates that I have over here ultimately affects the gradient look. Now I would recommend that since you've likely done a lot of work troubleshooting your UVs over here, you probably don't want to touch this interface anymore. So if you don't like how the gradient looks like right now, we could try to troubleshoot this problem directly in the shader editor instead, simply by either messing around with the color ramp, so switching some values to get what we like. Or another thing that we could do is actually try to change the position, rotation, of scale of those vectors that we got from the UV coordinates without actually tinkering this result that we have in the UV editor. So it's almost like working as a backup or a copy of the UV setup. What I mean by that is this mapping node holds that vector information. And what happens if I take those 3D coordinates and I increase the x coordinate of all of them? So by doing that, all the x coordinates are changing. It's shifting around the position, that's changing the color ramp, the result that we get from the color ramp, but it's not really changing the position of any of these models over here, which is good. So a little bit of experimenting with this might be interesting, but you're going to find yourself just playing around with it a lot and see what you like. Now, of course, in the example cube that we have over here, if you notice that there are parts in the cube that you don't like, such as where the gradient abruptly cuts off, one of the instances is at this vertex where we go to green to red pretty abruptly. Again, this is due to how your UVs are set up. So you might even decide later that if you want a very fluid transition of your cube, you might shift around these faces in like a straight line or something more continuous to prevent edges cutting off, which are probably around these edge areas that are not directly connected to the other faces. But that's not super important right now, just a little bit of food for thought. Okay, that's enough talk about the color ramp node. I'm going to show you of other cool texture nodes that might be interesting. So I'm going to disconnect this and put it off to the side. Now, the way that you disconnect the node from another is that you can take one of the wires from an input node and just drag it off into empty space like this. But if you try to drag it off the input node, the default behavior is that it's just adding a new wire to connect up to something else. But if you hold control on your keyboard and then disconnect it will actually grab the one that you already have attached. Okay, so move that off to the side, and I'm going to go Shift A to view a list of my presets, and I'm actually going to be talking about a few of them under the texture coordinates, which have a lot of interesting presets. So the first one I want to walk through and talk about is the brick texture. So the brick texture node, it's going to create a brick pattern, which I could see by plugging the color output into the base color. So right now, the bricks are clearly only visible on one side of the cube, and this is because we have the default behavior going on since nothing is connected to this vector input. Now, as you may have guessed, if we take the UVs of our cube, get the corresponding vector coordinates, and plug it into the vector input of our brick texture, then suddenly we have bricks that appear on all of the sides. So let's take a look at some of the options. The first one is offset over here, and this refers to how much the bricks offset from each other in every frequency number row. So if I set the frequency to 1, for instance, that means every single row is going to offset the same amount. If I set the frequency to 2, every second row is going to offset. And you could see that at a 0 offset, it's going to be aligned. At an offset of 1, it's going to be aligned to the next brick in line, which ultimately looks very similar to the 0 result, but the colors are slightly different. And of course, if you have it right in the middle at 0.5, then it's going to create a more standard casual brick pattern that you see. Next thing is that we have squash, and squash adjusts the brick's width in every frequency number of row. So you can see when the squash number gets smaller, the bricks are going to get smaller, and this is happening every second row because our frequency is set to 2. Now squash is actually a scaling factor, so when the squash is set to 1, it's going to be the same size as the previous brick. Smaller, we already see that it gets smaller, and a value larger than 1 will make it actually a little bit wider. Let's put it back to 1 for now. Moving on, the first two color layers, so color 1 and color 2, they act almost like a color ramp, but it's just choosing a handful of shades between color 1 and color 2 to set to the other bricks. So I could do, let's say, red for the first one, and we'll go blue for the second one. So we can see that there's some bricks with very red and blue values, and then the other colors that they're using, they're in some new shades, but they're not like a crazy number of different shades going on, just a handful of them. And then the mortar color changes the color of the actual mortar, so the cement part of the bricks. Now what's interesting about this is because all of these are color values, which have these yellow markers over here, if you want, you can even compare this with other color values. And one of them that we've seen so far is actually this color ramp. So for instance, what happens if I take the color output of my color ramp and plug it into the mortar value? Well, what's going to happen? We expect it to give us the salmon or pinkish color because nothing is connected to the factor, so the 0.5 value is being mapped to this pinkish color. But of course, we know that we could take this a step further by using the UV coordinates to give us unique factor values. And now my mortar value is gradient. But the actual colors of the brick stay the same. And I can even see what this will look like if I move them around. So here's another option. And with right pairings of these, you can create some pretty interesting results. But for now, we are going to unplug this so it doesn't confuse us. Okay, moving on. Scale changes the scaling of the bricks. So as I increase this value, we can get more and more bricks, so they're a little bit smaller. And the reason of why they're smaller is, again, imagine if I go to the UV editor. And behind this grid over here, imagine you had your brick texture laid out. Well, increasing the scale really does something the same as, let's say if I select this face and I scaled it up. Now, because this scaling face is bigger, it's going to hold a lot more of the information in the image behind it, and in turn, therefore show up a lot more bricks. So that's why increasing the scaling will give you this result. Let's just change it back to something smaller. Let's go 8. Next is mortar size. This is going to change the thickness of the actual mortar or the cement. Now, if you try to slide this yourself, you may notice that this value is actually quite sensitive. And even just by looking at it or moving it slowly, the numbers that Blender is jumping from is quite a lot. To get more control over this, you can actually hold Shift on your keyboard and then slide, which is going to decrease how much Blender jumps from one value to the next, allowing you to have a little bit more control. And holding Shift for any slider does the same thing, just decreasing the automatic jump value when moving, or increasing or decreasing the value. Mortar Smooth, so bring this, so yes, Mortar Smooth blurs the edges between the mortar and the bricks as the number increases. So if I do Mortar Smooth all the way up to 1 and I zoom in a little bit, you can see that the transition between the mortar and the bricks, they're very blurry. But if I go down to 0, it's a lot sharper. Next, bias refers to a color variation on a scale from -1 to 1, where a bias of -1 fully biases color 1, and a bias of 1 fully biases color 2. And if you put this number right in the middle, which is 0, there's no bias between the color. Brick width changes the ratio of the width of all of the bricks relative to your scale, like this. And row height changes the ratio of the height of all of your bricks relative to your scale. So there's it being squished as the number goes down, and then we get some tall bricks as these are going up. So as you can see, a lot of these options are either self-explanatory or very easy to interpret if you just play around with it and see what it does. This is good practice for you when you go off to explore all the other different types of nodes in the shader editor. And whenever you do get stuck, you can always search up the manual for that node online, and it will explain what each of these values does. I say this so you don't have to listen to me explain a ton of nodes for like an hour, but you are welcome to ask questions in the Discord about some of the nodes that are not explicitly covered here. Either way, we're gonna move on and let's showcase a couple more. So the next cool one or popular one that's found under texture is the checker texture, which is very nice and small. So if I plug in color to base color, very simply, color 1 and color 2 are your checker colors, and scale reflects the scaling of your texture. Now, the default value is very good at covering the entire cube easily, and you might notice that because the UVs of a default cube, Blender puts it in a T shape, these 4 faces are the lateral faces of the cube. And therefore, when we change the scale, the transition on the lateral faces of our cube, which is everything except the top and bottom, are pretty good. But if you have a very weird scaling, like a decimal, on the top and bottom sections, they're either going to be a little bit too thin. So you might need to configure around to see which ones work very well. And in this case, it looks like 16, 18, these are looking good. A lot of the other numbers, so 10's looking good. So almost every jump by 2, it seems like. But yeah, you could play around with it pretty well. And again, you could also pair up your vector with the vector input. And now it's going to use a new scaling, one depending on this UV island that we have here. And then you would need to also try to configure the scaling over here as well. Okay, so that's a little bit of something to play with. Another interesting node. And the last one I'm going to show you is the noise texture, which is also a pretty cool one. So the noise texture actually has two interesting outputs. We have the color as usual, and we also have a factor one. But let's start off with color since we've been doing that one a lot. So in this color node, the dimension and the type of how noise is calculated can be set. So the default one is FBM, but you could honestly play around with the other options to see what it looks like. The specifics of them are a little bit too complicated and out of scope, so any usage of the noise texture is simply going to be ones that you see or kind of vibe with, not really exactly understand the specific details of why it's looking the way it does. But some of these are very similar to us, so scale is going to change the scaling of the noise. Detail is going to change the number of noise octaves, which can either give you a pretty blurry shape or a more sharper result. Roughness blends between a smooth and rougher noise depending on the value. Lacunarity changes the scaling between noise octaves. So you can see we got some finer grittiness that's going on here. And distortion distorts the noises. Also, normalize if checked will normalize all these vectors that we have here between a value of 0 and 1. But if you uncheck it, then you're going to get some darker values and a lot more interesting colors. Again, a lot of that is not going to make sense off the bat, but that doesn't honestly stop us from playing around with it and seeing interesting effects or textures that we can create. That said, when we configure our noise imperfections, so you can think of noise as a little bit of imperfections, you can also experiment, what I like to do, with the metallic and roughness values. And the way that we do that is that the noise output also has this factor value, which we know is scalar. And metallic and roughness are also scalar values. So, if I plug in factor to metallic, like this, you could see that in all these little details that we have going on here, this is changing the metallic look of the cube. And you could do the same thing for roughness as well, which almost look like smudges. And you can even decrease the distortion a little bit so you get something that looks even more like fingerprints or just smudges around. And you can also plug this into base color, which is just going to give you a grayscale result. And vice versa if you were to plug in, color to metallic outputs for itself, which gives you a little bit of different values. And as you may have guessed, that if you're transitioning between a color value to a scalar value, some sort of internal transformation is going to be going on. But I like to say just stick with what makes sense, which is saving your color for base color or even factor for metallic or roughness. So there's some pretty interesting smudging effects or fingerprint effects that you can create with your noise texture. So there are many more, but I think this is a good time for me to step back, showcasing a lot of these designs to you or different nodes, and really let you get an opportunity to get a feel for the different types of nodes that the shader editor has to offer, and ultimately let your creativity run wild. So with that said, I'm going to transition with this cube and show you how you would do this process with the crate. So imagine this is your crate, or this is just a part of your crate. All you need to do is that when you want to change a material, you want to select a mesh that you want to set a material to and add a new material by pressing this double page icon over here, rename it, and then just let your creativity run wild. And you can see that when I create a new material, when there's already something here, Blender is essentially duplicating it, but under a different name. And at this point in time, you could just delete what you don't want and just work from there. So this is pretty good if you want a little bit of another starting point to quickly get through another similar related texture instead of just starting from scratch. And of course, the reason that you don't want to change what you have in the shader editor, so for instance, this material right now is example material 001. But let's say if you had, so here's another mesh. I'm going to move this one over here, and let's give this one example material 001 as well. Okay. Also, there's other textures in the dropdown. These are ones that I've sort of created and tested out, and you will see them soon. Anyways, let's say if you have multiple materials, the reason that you don't want to change a previously existing one instead of creating a new one is right now both of these cubes are referencing example material 01. So let's say with this cube that you have, I don't want to deal with this right now. Let's say if I wanted to change this. You can see right now that both of these cubes have updated to be the same material, and this is because they're both referencing example material 1. So yes, if you want something unique to this cube that's not directly correlated to this one, you need a new material for it. Okay, another thing that you could do is, let's say if we go back like this, another part that you could do is you could directly change your material in the materials tab over here in the properties. So if I change it to example material like this, and then change it, well, right now, this is a completely different material than what I have here. So 2 different materials, and I can configure the specific one however I'd like. And of course, you can use this X button to unlink a material like this, and then go through the traditional process of creating material from scratch. And using this minus button to remove a material slot is going to do the exact same. Just keep in mind that in edit mode, if you're trying to delete a material in edit mode, you're going to get an error. So yes, it's something that you want to do in object mode as well. So yeah, that's kind of just the gist of it for when you work on the crate by yourself. Select the mesh, change the material, have fun. But if you've gotten to this point and everything's sort of making a lot of sense to you, I'm actually going to show you a bonus tip of how you can set multiple materials onto one mesh. But please do not overwhelm yourself with this process if you're somebody who's still learning the ropes about creating basic materials. But if you are ready for it, and you are interested about how I can apply multiple materials on this one cube, then I'm going to show you that right now. So, the first thing you want to do is, let's say you want to go into, select the mesh that you want to apply multiple materials to, and we're going to go into edit mode. And because of our 3D model is made up of different faces, you have to select what faces you want to select different materials to. So let's say I'm going to just select these 2 faces. So on my cube, only these 2 faces I want new materials. To do this, in the Properties tab or Materials tab over here, you're going to click this plus button to add a material slot. And then with the faces that you want to assign a new material to selected, you're going to go ahead and click Assign. What you've done here is that you've assigned these faces to have its own material in its own material slot, which you can then set using the dropdown. So I'm going to set this one to example material like this, or you can traditionally create a new one from scratch as well. And of course, if you are working through this, so you can see that all the faces have the first material, and the new faces that I've assigned are referencing a new one. Now, at some point in time, you realize that you don't want to have these faces anymore, and you press this minus button to delete this material slot. Then all of those faces that were referencing it are going to go back and reference another one. So Control Z to shift that, and the same process goes. I can select the material I want to work with, do all my work in the shader editor, and ultimately have fun directly like that. But just know that because I have multiple materials over here, if I want to swap between these 2, I need to do it in the Materials tab over here on the right. I can't do it in the shader editor. Now, the reasoning for that is because right now, my cube is using both the example material and example material 001. And I'm actually going to change the color of this to make it a little bit easier to see. So we have a red and a green one. So right now I'm looking at example material 1, which is this red color. But let's say I want to fix up something in example material or the green one. You notice that if I try to use the drop down here and select the green one, then it's actually updated over here. So now I have 2 copies of example material. The 4 faces for this first example material, and then the other 2 assigned material over here. So by doing that, you sort of changed the actual material that is being assigned to those faces. And if you do any sort of funny business over here, such as changing the color, it's going to reflect to everything that's referencing under the name example material. Instead, if you want to keep the work that you have done, and now you want to switch to the blue color, you select it here, do all your changes here. And that's going to keep them separate from each other, and you're not going to accidentally cross over working on one material versus a second one. So yes, this is just a small precaution because you might find yourself editing something here, and then things that you don't want to change end up changing. The key is just to select it in the material editor here. Okay, so I did talk a lot about the materials in this lesson, and honestly, we've only gone through a very small fraction of all the possibilities. But you should now have the ability to design your crate however you please. So throughout this course so far, it's been a lot of follow along with me. But I think it's time now that I step back and really let your creativity run wild and shine. So, before you meet with me in the last lesson, take this opportunity to spend some time and create something unique to you. A crate design that is special, realistic, wacky, anything that's up to you. And I'm going to do the same thing with me. As a result, I'm also going to create a small 0.5 lesson in which I will showcase the design that I made for my crate and briefly explain on how I achieved the result. And that's just to prevent you from having to watch me go through the tedious process of designing a crate my way when really it should be about your way. But it's just there for your own curiosity and see some of the effects I can create just using the textures and nodes discussed so far. Anyways, this is a huge milestone for us, and I am super, super proud of everybody here of what we were able to achieve. So, see you in the next lesson, and until then, have a ton of fun designing.